Okay, I just forgot to record. I'll just recap it once. So we'll be importing the CV2 library here. Then we'll be using an inbuilt model from OpenCV, which you'll have to download it from the GitHub of OpenCV, and you have different models there. Under har cascade, you will find different for different body parts. You'll find different. So we'll be importing the frontal face because we are interested in face detection. Then I'll be using input image, which you'll have to put it in a folder, or you can just directly import it here. So I've put the path of the image for which I want the model to detect the faces. Then I'll be converting it to grayscale. So this is already a function which I'll be using. CVT color, I'll be passing the image, and I'll be using cv2 dot color to BGR to gray. Okay. Then I told you that once the model detects the face, I want the model to draw a rectangle over the face. So I'll be using this faces rect, and I'll be passing in that har cascade here dot detect multiscale, and I'll be passing in the grayscale image here. I'll be scaling it to a factor of 1.1, and I'll be using something called minimum neighbors here as 4. So these values you can change it and check how it will differ the output. So I'll do it and I'll show it to you later. So for now we'll take it as 4. So for finding the number of faces, we have a printf function, which is like number of faces found is nothing but the length of faces rect. Now to draw the rectangle around the faces for x, y, w, h. So x, y are the coordinates and w, h is width and height in faces rect. So cv2 dot rectangle, I'll be passing in the image. I'll be passing in the coordinates x, y, x plus w, y plus h. This is the color of the rectangle. Okay, what color I want. So if you know this indicates BGR. 255 here means it's blue color. If I put 0, 255, 0 means it is green color. And here I'll be putting a thickness of 2. Uh, then I have cv2.imshow. I want the final image to be shown, like the faces detected along with the rectangle. So imshow, and then I want wait key of infinite time. So I'll just run this. Before that, I'll just show you what the test image is. So here you can see there are 5 faces. So my code should give me an output of 5. So we'll check. Yeah, so you can see here, it has detected all the 5 faces, and I've also got the output here. Number of faces found is equal to 5. So now what happens is I told you that here minimum neighbors thing. So if I just decrease it, we'll see what will happen. I decrease it to 2. So you can see here that there's something else detected here. So this is, see, in OpenCV, it's like we are trying to improve the model, but it also has its own flaws. So you'll have to optimize it to the level you want it to. So here you can see that as soon as I decrease the minimum neighbors, it also started detecting something else as a face. But to increase accuracy, what I have to do is I have to keep minimum neighbors as a higher number. So this will increase accuracy. But if I keep on decreasing this, then it will also detect some other parts as a face. So this is for face detection. So we have seen in a random image how this model will try to detect the faces on it. So now we'll go to face recognition. Okay, so face recognition, right? I told you that you will try, the model will try to tell whose image is it. Like if I try to give an image of a cat or a dog, the model will try to tell which image is a cat and which image is a dog. So for that, what we have to do is first we have to train the model. So for training, I'll have to give a set of pictures to the model so that the model will try to learn. It will check for patterns in those images and it will try to tell, okay, this is this person. So that is how it works. So we'll have to create a py file for training. Okay, so I'll keep it as train.py. I'll be importing CV to as CV. This is compulsory everywhere, and numpy as np. And I'll also be importing one more library, which is OS. Okay, OS nothing but it stands for operating systems. So now what I'm doing is I have a set of 5 people here. Okay, Ben Affleck, Elton John, Jerry Seinfeld, Madonna, and Mindy Kaling. Okay, so these are the people who I am interested in, and I also have their pictures here. So if you see, I have a folder called Faces, and in that I have 2 more folders, which is Train and Validation. Okay, for training, I'll be using pictures. So I have 14 pictures for Ben Affleck. Then I have for Elton John, I have almost 17 pictures. So I've taken random set of pictures here. If you use many pictures here, the accuracy will be much better. Okay, so you'll have to keep some images for training and some images for validation. This is to test the model, okay? So once your training is done, if I randomly give an image from this, the model should tell whose image is it. So this is for testing the model. So here I've kept 5 images each for everyone. Okay, so I'll be taking this folder here, faces. So here I have the people, different people, and here I have dir, which is nothing but the link for this, okay, where it is present in my PC. So I have like put the link here, and then I have again har cascade because first I have to detect the face on the image, right? So I have to use this. Then I'll be creating two variables, which is called features and labels. For now, I'll keep it as null. Then I'll be defining one more function, which is called def create train. So for person in people, okay, people is a list of 5 people here, but I want for per person. So for person in people, I'll be using one variable called path, which is os.path.join, and I'll be joining dir to the person. I'll be making, you see dir is a link only till train, and I'll be joining this person to this. Okay, that is my path. Then label, okay, people dot index and person. That is labeling. I'll be labeling the people there as under this label. So for image in os dot list dir, okay, dir is nothing but directory and list directory. Okay, this is I'll be passing in the path here, and image path is equal to os dot path dot join path image. Then there's image array for which I'll be reading the image path, and then if image array is none, I'll be continuing. That means I'll skip this iteration and I'll run the whole thing again. So continue. Then I'll be converting it to grayscale image, the normal BGR image to grayscale. Then I'll be using again faces rect, which is same thing. You pass in detect multi-scale, you pass in the grayscale image, you scale it to a factor of 1.1, and it's always preferable that you keep this value higher. Okay, it also depends on your image. If the faces are really close to each other and if it is very crowded, you can use a lower value. But if the faces are very far apart, so you can use a greater value here. So for x, y, w, h, I told you this is x coordinate, y coordinate, width and height. In faces rect, faces ROI. Okay, ROI is nothing but region of interest. Okay, what part of the image has only the face? So that is the region of interest is equal to gray. Y to y plus h and x to x plus w. Then what I told you that I created two variables here, which was null. Okay, features and label I had created it as null. So now I'll be appending in. I'll be appending this faces dot underscore ROI to features, and I'll be appending label to labels. So now I'll be creating this train, and I want it to print training done once the training is done. Okay, it will be printed here on the terminal that training is done. Now what I want to do is I had uh, taken this features and labels, right? I want to convert this into a array. Okay, to convert into array, I need numpy. That's why I imported numpy as np. So np.array, I'll be converting all of the images which was put in features as array, and whatever labels were there into another array. Okay, so I'll be creating one more variable called face recognizer equal to cv.face.lp whatever. So this is nothing but inbuilt function again, which is used for face recognition. Okay. So now train the recognizer on the features list and the labels list. So I'll be passing in this face recognizer dot train, and I'll be passing in the features and the labels which I have converted it into an array. And now what I want to do is I want to save this as a YML file. YML file is nothing but a human readable file. Okay. So this can be used for further purposes. So I'll be converting it to YML file here, and I'll also save this numpy array as features.npy and labels.npy. So this is what we do in the training file. Uh, so now we go to, so yeah, if you see, right, this is the YML file which is created. So you can see this is human readable. You can read what's the threshold value, what is the radius, how many neighbors. So all this is human readable file. So you convert it to YML so that you can use it for later purposes. This is the NPY file which was created for features and labels. Okay, it's not visible here because it's all in binary bits, so it's not readable for us. So that VS Code is not able to show it. So now we'll go to face recognition. So I now what I've done is I've done a file called train, and the training is done. Okay, if you want, I can just so it was here. You'll have to run this. Okay, I've already run this before. So if you run this, it will show that training is done. So you can see here, see, training is completed. So once training is completed, then I can go to face recognition. So here I have again input numpy as np, input cv2 as cv, and again I'll be passing in the har cascade here because yeah, to detect faces. Then again I'll be passing in the people list. So for now, this just ignore this. Face recognizer again I'll be passing in the inbuilt function here, and I'll be passing in a read. Okay, face recognizer dot read, and I'll be passing in the YML file. You see, I can directly just import it here. I don't have to do everything again. So that's the advantage of converting it to YML file. Now what I'll do is I'll pass in a image from validation. You can see here I had a separate thing called validation here to check the model. So I'll be passing in the image from here. So this is nothing but the path of the image. Okay. So if you see, I have passed in see validation here from VAL and Elton John, and I've passed in this image. Okay, I've passed in this image. So I've passed in that image here. So I'll be converting that image into grayscale again. Then I'll be passing in this again faces rect to detect the face. Again, everything this is discussed in previous thing only. So now I have something else called label and confidence. Okay, label is nothing but I want once the face is detected to label whose face is it. Now you saw I had passed in Elton John's picture. So I wanted to label whose image is it. Okay, I want the label Elton John to come. And confidence is nothing but how much percent the model is sure about it. Okay, you'll see that later when I run it. So face recognizer dot predict. I'll be passing in this faces and region of interest, and I'll be printing this people label with the confidence of this. So I'll one more thing I want to do is I'll put in cv.put text here to tell me whose image is it. Okay, I'll be passing in the image. I'll be passing in the string that is people label. 2020 is nothing but the coordinates of where I want the text to come. Cv dot this is the font of the text. One is nothing but scaling, and here this is nothing but green color. Okay, the text will be in green color, and the thickness of the text is 2. And then I'll be drawing a rectangle on the face. So I'll be passing in the image, I'll be passing xy coordinates and x plus w and y plus h. Again, I want the rectangle also to be green, so 0, 255, 0, and thickness is 2. And then I want to show the image in a new window, which is called detected face, and I'll be passing in the image. And weight key is 0. So now I'll be running this code, we'll see what happens. So yeah, you can see the model has detected the right thing. This is Elton John. So you can see the text is also here, which is green in color, and it starts from coordinate 2020, and it also drew a rectangle on his face. So you can see this, and here, if you see here on the terminal, it says label Elton John with the confidence of 90%. So the model is sure that 90% this is correct. So yeah, this is for face recognition. You can test it for anything. Uh, you can just change this here. Okay, in place of Elton John, I can also put 2. So yeah, see here. Here the problem is this model is again not very accurate. So you can see this is Elton John itself, but the model is saying it's Jerry Seinfeld. So this is one problem with this. It's not very accurate, but you can make it accurate by changing some things here. Uh, None of the models which exist are 100% accurate. Okay, so sometimes, so if you see in this picture there's a lot of noise. If you have a picture only with a face, like clearly just a face, then you can, then the model will predict it like properly. But here if you see the face is just this much and everything else is like too much noise here. And if you see with a confidence of 129, so this is above 100%. So this is an error. So not every model is like 100% accurate. You can check it for everything else. See here it predicted accurately because you see most of the picture is just his face. So it predicted Elton John with a confidence of 67%. Okay. So this is for face recognition. So we have completed with today's session. So we have seen how face detection works and how face recognition works. Uh, so if you have any doubts, you can ask now. I'll be sharing all the materials, the code, and all the images, whatever I've used in this on MS Teams file section. So you can try it on your own. You can actually try with some other images also. You can build your own model. Just try once. If you have any doubts, you can ask. Otherwise, you can leave the session.